Hey class, Mr. Houston here. Today we're into Chapter 6, Lesson 3. We're going to be proving triangles are similar. In today's lesson we are going to be using AA. If you remember back to Chapter 4, it's pretty much through angle. If we can prove that we have two congruent angles in corresponding triangles, then we can prove that the triangles are similar. Okay? Remember, this is all about similarity. Similarity means same shape, not the same size. Okay? So, add this to your postulate sheet, postulate 22, or postulate or angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two angles are similar. Because, let's just throw this out here for just a quick second, if we know that two of the angles are congruent, we automatically then know that this third angle is also congruent. So this one would be congruent to this one. So angle. Okay, so we're going to use that to determine some missing measurements, or we're going to use this to determine if they are similar or not. So example 1, we're using it. Determine whether the triangles are similar. If they are, write a similarity statement. Okay? All right, so in looking at this, we already see that we have two right angles. So there's one of our A's. And then we see that we have 26 and 64. So from what we know here, no, we do not have enough information. But just using some simple math, we can determine if there's any extra information there that we need or that we can use just simply by figuring out those missing angles. So the very first one, we'll just do it once. So for triangle CDE, we'll take 90 plus 26, which is 116, and then we'll take 180 minus 116, and when I subtract that, I find out that this gives me 64. So this missing angle measure is 64. So right now, I have my 90-degree angle, and I have my 64. So I have two angles that are congruent in two different triangles, which means these triangles are similar. So we need to write a similarity statement. So let's start with the smaller one. We'll go triangle CDE. The key to writing similarity statements, and I think we've talked about this before, is writing them in the corresponding order of which you've already written. So I need to find the angle that corresponds with C. C is 26 degrees, and the one we didn't figure out over here is K, and it's 26 degrees. So K would start it off. D is my 90 degrees, so it would be KGH. Okay, so that is my similarity statement, and we know that by using the AA similarity postulate. Okay, now it's kind of going back to proofs and that. Now we have to show that these are similar. All right, so again, we are trying to use AA. We are looking for two angles that are congruent in the two different triangles. So if I look here, I have two triangles. I have ABE, and I also have triangle ACD. Okay, so as we can already see, this angle is congruent to this angle. We know that. The question is, can we find another angle that we can prove is congruent? And it's kind of like back to when we were proving triangles when they shared a common side. It was reflexive. In this case, they're not sharing a common side. They're sharing a common angle. And if you look, it's very simple to find. Angle A and angle A, which is this one right here. Okay, so they share angle A. So we have found our two angles. So basically, there's nothing really to write. You just have to show, you may have to say that angle A is equal to angle A. That helps us prove the angle theorem. All right. Letter B gets to be a little more difficult because they don't give us anything other than these two marks right here, which if we remember, that means that these lines are parallel, okay? But before I even jump into that, I'm going to look at the fact that these two lines are crossing, and if we remember, when two lines cross, they create two sets of vertical angles, and vertical angles are congruent. So I know right now that those angles are congruent, right, by the vertical angles. So maybe I say something like angle TVU is equal to angle RVU. S. And I could just maybe say vertical angles. Okay, so I need a second angle measure in order to prove that these are similar. So how we do that is, again, by knowing that these are parallel. If these are parallel, a couple things I can prove here. I know that this angle is going to be congruent to this angle by alternate interior angles. I also know that this angle, I probably should have put more marks there, so we'll do 2 there, 2 here, and this would be 3, by alternate interior angles. So you can take your choice on which one you want to use. Maybe you want to say angle RSV is equal to, so RSV would be TUV, angle UV. And you would just say our alternate interior angles. There we go. So we had our angle and our angle, so AA does work. All right, let's take a look here at the last one. Put this into kind of a real-world perspective. So a flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? All right, so we're going to set up a proportion. We are going to set, if you come over here to the drawing, you have the woman and her shadow, you have the flagpole and its shadow. So I'm just going to say that X is going to be congruent, or I'm sorry, similar, proportional with X, Y, and Y. So I know the height of this lady is 5 feet 4 inches. So because my shadow is in inches, I'm also going to change all of this to inches. So 5 times 12 is 60. 60 plus 4 is 64. So 64 inches on top. That is the height of the woman. We don't know the height of the flagpole. That's what we're trying to find. So we'll call that X. Next, I need the shadow of the woman, which was 40 inches. And the shadow of the flagpole was 50 feet. And then we just simply go back to the way we did our proportions before. We're going to cross multiply. We're going to get 40x equal to 64 times 50, which is 3,200. 3,200. Then we will divide by 40 on both sides. We're going to get x equal to 80. So the height of the flagpole is 80 feet. That would be answer C. Okay? So again, as long as we have two congruent angles in triangles, we have similar triangles, and we can use that to set up proportions to solve. I highly, highly, highly encourage you to work your hardest at figuring out these proportions and understanding how to set them up and how to solve them. If you have any questions, please bring them with you to class, and we will see you then.